And if you are following me in my previous lecture, we try to plan some initial connectivity, and we saw that when we are given some sites on initial basis, we should not be accepting the site as it is because it may not be a good match as per the connectivity requirement. So we may request our radio teams to move aside a bit so that the connectivity becomes easy, and we see that what are some of the initial obstacles. For example, if there is any hill or anything is coming in between, then how we mitigate those issues. So now we should go a bit further. For example, for these three sites, or just to reiterate, let me connect one more site. So we connect a site and then we make a terrain data, and now we see that this site looks a bit visible to me. Let me add. Normally this looks to be a green area. I'm not very much familiar, but let me add some vegetation, and then we will see that if the antenna heights are clear. We can see that antenna heights are very clear. Even on just 5 meter these are clear. But we can then put them as per the given. For example, if we have a general learning that there are 50-meter antennas, so this is how our initial connectivity is made. So this has been initially done. When you finish the initial connectivity, it asks you to save this. It will be saving as a site A towards site B. This site should be site A and this should be site B. You can change the naming if you like, and then you can save it here. If you want to change the names, you can make it site 31 to site 30, or if you want to add something in the name, you can add it here, and then we save it. So we make some connectivity now. As in last one, I was saying that also this connectivity, the initial connectivity is quite important, so that we know that if this is our data center, we will make it high in frequency, then the next one will be low, then the next one will be high, then the next one will be low. So we'll make a high low swap, because the transmit can be high on one side or it can be low on one side. If we keep a site as low and high both, it is called a high low violation, and it can bring some problems in your interference. So we kind of finalize some links. So after making the initial connectivity, the second thing that we have to do is that we have to put the actual antenna and other things in it. So when I go to transmission analysis, first we have to see a few things. For example, we have to see that this is in an adaptive modulation mode here. If you can see, this is taking a Wiegand's Barnett as the calculation for our multipath and other things. So if you see here, this is multipath fed algorithm is Wiegand's Barnett. It is showing that this is in kilometer and meter. You can change it to miles and feet. This is the TR. I will make a video on it. This is showing us that what is the general path profile data that we have. This is giving us a DNDH curve. I will show these all separately, but for us the immediate 2-3 things to check is, first is the adaptive modulation. We have two type of microwave currently. One is that which works on adaptive modulation, and some work as a normal microwave. The main difference here, if you see, it just changes a kind of dish symbol. The main difference between microwave and adaptive modulation is that the adaptive modulation radio can change the modulation type based on the weather condition. For example, if it is raining, it will lower the modulation, because lower modulation will increase the threshold of the radio, and the radio will become more robust. I will show you that as well in a different video, but this is, I want to tell you in simple words that when you are planning a link, you should see that what kind of radio files you have. If you have the auto adaptive modulation files and your requirement is to plan in adaptive modulation, then you should change it to adaptive modulation. Otherwise, you should change it to microwave. Also, if you have any requirement to change this, you don't want to use vegans, or if you want to change it to I will go in detail of this, that what are these each one, but if you have to change it to anyone else as per your any requirement, then you can change it from here, like you can change it to 530 or anything else. For diffraction also, I mean obstruction fading method, you can use it any of these methods. So this part give you a option to change the calculation method of how the path loss will be calculating a lot of things. Specifically, it will be calculating the multi-path based on this. And okay, I have changed it. Let me just take it back. Or we can put it, because most of the people now they are trying to work on this 537 by 8. And you have to see on these two values. One is giving us everything is fine, one is saying everything is wrong, because we have not put anything up till now. So for example, if you are fine, you know that this is adaptive modulation you have to take, and you should be using one recommendation P537 by 8, then you will start filling these values. You will put which antenna you need in. There is the antenna name. If you know the antenna name, then it is very good. If you don't know by the name, you can see that this model, which has this file, it has a gain of 37, diameter of 1.2, and it is in the 7 gigahertz full range, 7100 to 8500. Let me put it for the time being. And similarly, you have to put a radio file. So this radio file also works in almost, sorry, this is 70. This radio file, these works in what frequency we have already, because it is part of that, because that was 7100 to 8500. So we are within that frequency. So if you see in the name of this radio, this is a 14 megahertz. This will take 14 megahertz frequency channel. This is for 28 megahertz. This is 40 megahertz. This is 56 megahertz frequency channel. And these are 7, and this is again 14. So you can see this is also 14, and this is also 14. So the difference is that this is 2H16QAMS. This has a S in it. The other one don't have a S in it. So you should be kind of fully aware that what is the difference. If you see, the S1 has a maximum throughput of 35 mega, but without S has a higher throughput. So you should know these differences, because for different vendors there are a lot of different type of radio. So you should exactly know that which radio you have to use. For the time being, I will be using this 56 megahertz radio. When we go on it, we have to choose a bit of things here. I will make a different full video on it, but for the time being we don't change anything. We say okay, let's go ahead and let's use it. You see, as soon as I added, a lot of things are calculated except this annual rain, because we have not added the rain up till now. So I will add the rain file, and now this rain value is also populated. And if you see here, these two checks are green. It means that both of these checks are Path loss has done its own checks, and based on the checks, path loss says that this link looks to be working fine as per the recommendations which are provided here. So apparently it looks that maybe everything is done, but one thing is not done. What is not done is we have not provided the actual frequency that this link will be using. Let me close this link. This link is from 32 to 34. So this link is from 32. This is 32 and this is 34. I close it just to make sure that where I am. So as we were talking, we have to make 34 as high. We thought that we assume that this is the data center, we have to make it high. So let me go back, and now I will go to this 34, and now I have to place the channels because I have not made a channel file up to now. This I will also show you in a different video how to make these files, how to work on these. But for example, I will give it the name of channel 1. I say that this should be 8200. Polarity will be vertical. Okay. Sorry, this is side 32. No, so side 32, I will put it as 70. What was the range of our radio? Because I don't use Huawei a lot, I don't remember it. But for example, it was 77,500. So this is channel 1 low, and this will become channel 1 high. When I will show you how to make the channel file, then these things will become very easy for you. Currently, we can see that this is not a very easy thing. So this polarization, if we double click, it changes. So if for initial links, we keep it vertical. If we make a same link in the same frequency, then we make it horizontal because so that we can keep some difference. And so asking to update the frequency, I say yes. You see here the frequency is updated. So now we can say that the link is fully planned. So we have the link values. If you see here on 1024 QAM, it will be working on 453 megabit per second, but the fade margin is only 19. So in the best weather, it may go up to this as well, but for assumption, we assume that most of the time it may remain somewhere between for this 30. 30 is the one, or almost 30, because this is 31, this is here 31, this is 28. So we report this link on some value like 364 or 370 kind of value. We don't report this link for 432 because 432 is a kind of bonus for this link, or 453 is the extreme bonus for this link. This link can go to 453 megabit in a best weather, but as this link may drop to 174 as well in the worst case scenarios, so we report this link in the almost middle, or the place where the thermal fade margin is near to 30. So it will be a kind of, it will be used as a 364 megabit link, even though sometimes it may be giving a bit higher values. So I hope that this lecture should be beneficial for you, and you should have learned that how we complete a link plan. Now this link is technically, it is a kind of planned fully. There are a few steps which I will talk in the later videos, but when we complete the initial connectivity, then we populate the antenna type, the radio type. We see that what kind of microwave we want to use, adaptive modulation or the normal one, and what kind of calculation methods we want to use. And based on that, we complete our planning. We put the drain system as well, and then as a final touch, we provide the frequency channel. So at that time, this link is now complete. The next step is when you will change anything, it will ask you to save. And the next check is we will not be doing right now. I will show it you later. But if we have a full network fully planned with all the frequency channels, then after adding a few links, we do a interference analysis, and that I will show you in some later video. Up till that time, hopefully, I will add some more links as well, because to make a good frequency interference analysis, we have to have some real links here. So see you in my next video. Goodbye. And if you like the video, then please subscribe to my channel and share this video with your friends so that they can also learn. Okay, goodbye.